Okay, you guys, I got number 23 and 27 on tonight's homework. Um, 23 I was playing around with a little bit, and there's definitely two different triangles here. This one, which brings in this XY coordinate, and then this one, which is going to use the DSDT. This particular segment then can be called the 12, like the whatever y value we're at, 12 minus that y value, we'll leave the remnants for the top. Anyway, this one gets away from me quickly. It's way too complex. Don't worry about it. No big deal. You essentially differentiate this triangle, and do some substitutions, and some algebraic playing around that probably not many of you would dream up on your own anyway. So let's just let that one go. I'm going to make my note to not include that next year. On this next one, number 27 was the baseball field one. So they say it's a baseball field. Here's home, first, second, and third. Between each plate is 90 feet. Well, here's a runner running this way from second to third at a rate of 25 feet per second. But that means this is shrinking at 25 feet per second. So D8, I'm calling this A, this side B, and this side they called S for us. So DADT is negative 25, and they want to know at the moment that runner is 20 feet away from third. This is still 90, and this rate of change is 0. And then they're asking us, at this moment, what is DSDT? We first need to find out what S is at that moment. So let me just read this question again. Yeah. So A squared plus B squared equals S squared. B is 90. And so I'm going to differentiate 2A dAdt plus 8100 equals, oh no, I'm differentiating. So 2A dAdt plus 0, because that's a constant, equals 2S dsdt. So solving for dsdt, we just really need to find S and divide this over, because we already know A is 20. dAdt is negative 25. And 2S we're going to find in dsdt is what the question is after. So to find S, we just need a Pythagorean theorem. 20 squared, I'll go over here, 20 squared plus 90 squared equals S squared. So S is the square root of 400 plus 8100, which is the square root of 8500. So that's 100 times 85, I know that, which is 10 root 85. If I can think of any other perfect square that goes into 85, I'd be in luck, and I don't think there is. So we're just going to call it 10 root 85. And then divide this 2 over. Divide the 10 over, which will make that a 2. 2 negative 25 equals root 85 dsdt. And divide both sides by root 85. So you got negative 50 over root 85 equals dsdt. So sorry about 23. Hopefully we're good with that. And a little review day tomorrow, and that's really related rates. It's tougher. I think some people find it simple. I do typically lose some people who this, it's flying over their head. So I'm not sure how that's going for you in the virtual learning world. But you got an exposure to it. So when you see it in BC Calc, it's not crazy. Obviously, you can go back and brush up on this. My website will be live all summer. But after this, I think we'll be moving on to the next chapter. So tomorrow, I think it's just like working on a review packet and no video, I think. And then next week on to just back to kind of derivatives and what derivatives tell us about features of functions that when we're looking at images of functions. So, anyway, I digress. Have a great night, and I'll probably hear some questions from you tomorrow.